Hello, everyone. It is great to have you all here. I think it's going to be a great session, and we will all can learn from it valuable things. I'm Asaf Echt, a team leader of one of the technical research team at CyberArk Labs. The team and I did lots of research work around cloud and modern authentication and authorization techniques. Today, we are going to dive into the minds of the attackers and talk about how they see the latest security trends of passwordless and single sign-on. Are these promising security concepts indeed bulletproof? Let's start. Well, the best way to start the session is with something personal to break the ice. Like I guess many of you, worked a lot from home last year due to the coronavirus situation. And one day I saw this nice guy with his dog in the background and just felt the same because I also have a dog running around my house. So the video captures my daily feeling.
Maple, can you stop just for a second? 3, 2, 1. More cold air. 3, 2, 1. Cold air continues across the area tonight. Potential for some frost and freeze for some of us. Warm up, it's going to take... Hey, come here. Come here. Come here. Sit. 3, 2, 1. Frost and freeze for some of us again tonight. The cold air is lingering through much of the week. We'll show you when the best chance of precipitation is with Futurecast. Maple. 3, 2, 1. Maple, excuse me. Hello, come here. Come here. Come here. Do you want to be in this tease? Is that what you want? Come here. Just lean up here. I can do this. 3, 2, 1.
Well, so do you also feel like him sometimes? Personally, I do. Anyway, let's begin. Modern environments are built from hundreds of devices like laptops, servers, mobile phones, application, and cloud services. And they are all connected together with thousands of cross-communication and serving access needs. The way that these access requests are being validated are with secret element that only the valid identity source should know. Most of the time, it will be done with passwords or binary keys, like SSH keys, cloud access keys, and so on. From the attacker side, these passwords and keys are the main targets. If the attacker is succeeding in the efforts of stealing these secrets, they can easily impersonate the compromised identity and do whatever they want on the victim's behalf. For long decades, these passwords and keys are the core problem of the cybersecurity field. We all can agree that the amount of these passwords and keys is huge. Just think yourself, how many passwords do you have? Right? How many online websites and systems you are registered to? And how it's awful to manage all these passwords and also click them again and again into different applications. That's why in the recent years, the world introduced two promising concepts. The first is passwordless authentication, and the second is single sign-on, also known as SSO. With SSO, user can authenticate once, and afterwards they can access all the connected devices and services. Therefore, the users only have one password. So it should be easier to make the password stronger and protect it better. Now, does it really protect us from attackers? Well, the answer is it's complex, but in the bottom line, not. No, because there are two major breaking points. The first is the initial authentication. Many times it is still done with a password. And we know that passwords are still one of the weak spots. Definitely when it is used by human users, we tend to use weak passwords, we use them, and even tend to write them down on a piece of paper. And on top of all, they are easy target for phishing attacks. The second breaking point is after the SSO is completed, the initial completed the initial authentication, there is an identity token that is valid to multiple services and resources. If this one security token is compromised, all the related services are compromised with it. Moreover, it will also bypass multi-factor authentication because the SSO token is being issued after the multi-factor check was passed successfully. So we don't love password, and that's why passwordless gaining more and more popularity. With passwordless methods, you can authenticate yourself with biometrics attributes like face recognition and fingerprint, or using a simple PIN code. And in the background, an extra layer of security was added that is using the local TPM of the device, the Trusted Platform Module. And after all of this, does it help? This is what we are going to discuss. Let's dive into the details and see what attacker can still do. First, we will focus on passwordless trend. Microsoft leads the market with their great and popular solution, Windows Hello. With Windows Hello, you don't need password anymore. Of course, only for the things that Windows Hello supports and currently has integration with, but it becomes more and more. You can have a Windows Hello for business in the network environment with Active Directory and Azure Active Directory, or even set it up locally without external Active Directory and replace your local login password. To be clear, under the hood, there are still passwords to every user. The user will not need to use them regularly, but their password still exists for them and stored in the Active Directory, just like before. With Windows Hello, to each user will be added additional authentication method, additional keepers, I would say. And Windows Hello authentication is built on top of key-based and certificate-based authentication. Again, in simple words, you can think of a private and public keeper. The public key of the Hello mechanism is being stored in a new attribute in the Active Directory that you can see here. It's called MSDS Key Credential Link. And the private key of the user is stored on the device itself. In the best case, the private key will be stored inside the local TPM. TPM is ultimately a physical trusted platform module that makes the private key inaccessible for the operation system and prevent remote access to the keys from the network. You can see here a nice diagram. Now, here come the tricks. The private key in the TPM is secured by a passwordless method. It is locked unless the passwordless method was successfully passed. In Windows Hello, these methods could be using face recognition, fingerprint, PIN code, and more, as you can see in the picture. Only when the initial passwordless check was passed successfully, then the private key is unlocked in the TPM, and the domain authentication process is starting with the Active Directory. In general, Windows Hello is a great thing because the private key never leaves the local device and supposedly cannot be extracted by regular users and used from a different computer. If a user configured Hello on different machines, there will be different unique private keys for each one of these machines. Hello is also considered as a multi-factor solution because it involves a key or certificate that is tied to the physical device. And there is also the additional method for starting the Hello authentication process, if it's a biometric element or other secrets like a PIN code. Here you can see the full authentication process. First, the user starts the process and needs to pass the face recognition check, as in the second example here. Then, the private key is unlocked from the TPM and is used for starting a Kerberos authentication in the domain. The Active Directory validates the usage of the private key against the related user's public key. And if the validation is successfully, the authentication process is completed by sending a TGT, ticket granting ticket, to the endpoint. From here, the access to the resources by the endpoint and by the user are the same as before, as being done without Windows Hello. You can see the Hello only changes the first authentication phase and not the ongoing process of accessing the network resources after the first authentication is completed. So sounds great, isn't it? But what the attackers still do? This is our main goal for today. Well, the fact is that most of the Active Directory attacks still work. The reason is Windows Hello just changes the first authentication step. After this, it's still Kerberos and NTLM authentication in the environment. Therefore, attackers can still perform the notorious domain attacks of pass the hash, pass the ticket, and overpass the hash. And this is one of the important slides here. We should all realize this one. And let's see a demo for pass the ticket attack in an environment that has a full adoption of Windows Hello. Well, here is an endpoint of a user named you. You can see you can log in with a password and with a PIN. Now I will log in with the PIN code. It means that I'm logged in currently with Windows Hello. Now I locked the computer and changed the user for an administrator. I'm loading Mimikatz and performing the logon passwords command. And you can see here, user U, also even when it's configured with Windows Hello passwordless solution, it still has NTLM hash. Now what about Kerberos tickets? I will use Mimikatz to export them from the memory. Here they are. You can see that the endpoint, the machine, and the U has Kerberos tickets, even in these passwordless methods. Next thing, as an attacker, I could take these Kerberos tickets and copy them to a different machine. Now I'm changing the look to a different server, and I'm logging in to the different server as an administrator. Next thing is, you can see here the Kerberos ticket, the 3 tickets I copied earlier. Now you can see that currently in my memory, the LDOS memory, there are a bunch of Kerberos tickets for the administrator user. I remove them. You can see currently there are no tickets in the memory. The next step in the pass the ticket attack is to use Mimikatz to load the copied Kerberos tickets of you user to the memory. Here it is done. You can see that I loaded the TGT of you into the memory, but I still an administrator. Now when I'm doing action on the network, you can see that TGT is getting more TGS for the U users. And this is how pass the ticket attack still happens in passwordless authentication environment. In addition to all the popular domain attacks that are still valid in Windows Hello environment, there was also some attack surface around Windows Hello itself. The researcher Michael Grafenter described 3 attack vectors in the past. Injecting a Windows Hello key into the user. In this attack vector, the attackers injects a custom NGC, next generation credential key, to the user Active Directory attribute. The attack steps are generate an RSA key pair, create NGC blob from the RSA public key, write the NGC blob to the Active Directory, and authenticate using PKInt. Prerequisites to this attack is to have write permission on the target user account. That means it could be done only as a post-exploitation action, but it's still useful for attackers. In addition, Windows allows keys that were created by TPM version older than 2017 are vulnerable to be cracked in an easier way. You can see the publication about this Roca vulnerability that made big waves a few years ago. Another thing is when someone sets up a Windows allow, the allow's public key is written to the on-premises Active Directory and also to the Azure Active Directory. And this key is tied to the user and to the device. If the device is removed, its attached Windows allows key is considered orphaned. However, these orphaned keys are not deleted, and sometimes even if their corresponding device is removed. While any authentication to Azure Active Directory using an orphaned key will be rejected, some of these keys cause security issues in Active Directories on-prem in the version of 2016 and 2019. So be careful. Now it's time to talk about single sign-on. Most of the organization progressed in the recent years to hybrid networks, architectures. In hybrid environments, you can easily enjoy the advantages of both worlds, right? The cloud and your old on-prem systems and networks. The connectivity to the cloud could be done with different IAM and single sign-on solutions, with federation solutions like ADFS, and also there are a few synchronization solutions like Azure AD Connect. In the case of Azure AD Connect, you can install it on an on-prem server, and it will connect and kind of replicate the on-prem Active Directory to the Azure Active Directory. In that way, all the users could also be authenticated to the cloud in a convenient way over the internet and from anywhere, and then access the different online application without any limitation of being inside the on-prem network or using VPNs. The synchronization also applies to the domain device accounts. A machine in the hybrid environment will be defined as a joint device both in the on-prem Active Directory and in the Azure Active Directory. Here you can see an example. On the right, you can see the on-prem domain of the machines. And on the left, you can see that in the same time, the machine is also defined as an Azure AD join device. In addition, you can see the connected Azure tenant ID and tenant name. In hybrid environments, there are many advantages, and the related one to our talk is the ability to do an out-of-the-box SSO. You log on once to your local machine and then can access different and more cloud services and online applications. You can access these online services with your web browser. In Chrome, there is a great extension by Microsoft that will do the connectivity work for you. And in Edge browser, this functionality comes built in natively. Here is an example to a list of several connected online applications that I can access automatically with my previous initial authentication and without the need to enter my password again. This is a great thing. Now, a short background on modern authentication and authorization. We have the OAuth protocol, which provides authorization and access to resources. And we have OpenID Connect that is based on OAuth and adds a layer of authentication and SSO capabilities. Both are super, super popular. OAuth is built from validation of different securities tokens. First, you get the refresh token, and with it, you get an access token. And with the access token, you are being authorized and get the final access to the desired application. In the case of Azure Browser SSO, here is the main scheme. The user logs on, then gets a PRT, primary refresh token. The PRT is more of a long-term persistent token that reminds the ticket granting ticket, the TGT, in Kerberos, in the domain Active Directory. With the PRT, you get a PRT cookie that is in a JWT structure. Then, to access the online application, the PRT is in use for getting refresh tokens and access tokens, like we saw earlier in the OAuth logic. In real life, in this process, there is some more complexity and some use of dynamic and derived keys that add more security. These keys are issued per device and per session. The question you should ask yourself is where all these keys are being stored on the machine, because they are sensitive, right? They are providing access. And here is the answer. The PRT is stored in the TPM or in the registry if no TPM is available. And the PRT cookie is stored in the LSAS memory in the Cloud AP, one of the authentication packages. The refresh and access tokens are used a lot by the browser, and they are stored by it by using, for example, DPA API mechanisms. The next, an important question from the attacker side, is how you can extract these keys and what are the required privileges for doing it. You can see that with local admin rights on the machines, you can extract the PRT itself and therefore steal the entire SSO authentication context. And even without admin rights, attacker can still access the browser data of the compromised user and then impersonate his SSO context and access on his behalf or her behalf the target application and make lots of damage. Here is a summary of the two attack vectors we discussed. With regular user privileges, attacker can request regular refresh tokens, like the user, and access Azure AD connected resources. Additionally, with local administrator privileges, attacker can extract the entire PRT and even use it from different machines. Very risky. That is how a new attack is introduced to the world. The attack of pass the PRT. This is what we described here. The amazing thing is that it's already supported in the famous Mimikatz tool. And you can see here a tweet by Benjamin Delpy. So great research work in the past in this field was done by Dirk-Jan Maloma and again Delpy. And you can see here another tweet on the proof of concept they did on these methods of attacking the browser SSO. When talking on OAuth protocol, it's important to also mention the weakness in OAuth application that our CyberArk Labs discovered. We called it Black Direct vulnerability. In every OAuth application, there is a list of URLs that the tokens are allowed to be transferred to. This is also known as the list of the allowed redirect URIs. In the research we did, we discovered often URLs in sensitive OAuth application, and potential attackers could register these subdomains to themselves and then hijack the security token of this sensitive application. Here is the main flow in OAuth. The user browses to the target application, office.com as an example. The application, the online service, redirect the user to the authorization server for getting his access token. Then the browser sends a request to the authorization server for creating access token. The browser gets the access token, and with it, he provides it to the office.com and get his data. And here is the attack scenario when attackers exploit Black Direct vulnerability. When they took over a subdomain that was trusted by one of the OAuth applications. The client served to the compromised subdomain. Then the subdomain that is being handled by the attacker is transferred him to the authorization server. And the authorization server provides and creating an access token And this time, the access token is being sent to the attacker's server. And in his turn, he can access the user's data on his behalf and do whatever he wants with it. The reason for this vulnerable OAuth application is because it is an hard task to correctly manage all the connected subdomains. You can see on the right some real examples for the orphaned subdomains URLs that we discovered and were reported to Microsoft. So it's okay, they are fixed now. But you can see they are quite complex subdomains, but still they are important ones, and the application trusts them. Access token could be sent to them. As part of this research, we develop and publish a free scanning tool. You can see you can easily scan your environment by going to this website here, black.direct. Many companies already scanned themselves and were amazed by the findings. You can see that in the average, there are about 6 vulnerable URLs in each company. So we recommend you as well to scan your OAuth application and their trusted URL. Then be sure to handle the orphaned URLs that the attacker might take over. Protect your OAuth application before something bad happens. That's it for today. Let's talk on what you can do for mitigating the attack vector we discussed. First, make sure all your SSO and passwordless solutions are implemented according to their best practices, and make sure to install the latest updates. 10, focus, and this is the most important step, focus on the important things of securing your privileged accounts, including local admins, sensitive application, and your remote access procedures. Remember, if the security fundamentals will be compromised, SSO and passwordless will not help, and the attackers will celebrate with the attack vector we covered today. In addition, we recommend on performing periodic scans for the threats we presented, including removing unused Windows Hello keys, go through the login logs in your environments, and scan yourself against Black Direct vulnerability. To sum it up, we reviewed real-life threats in the field of passwordless, SSO, and OAuth. More details are available online. We invite you to check them out. Follow the best practices when implementing these new technologies. And the most important thing is ensure the security fundamentals are in place, like protecting the access point of your network and secure your privileged account. Thank you for joining the session today. I hope you learned several important things, and if you have any question or feedback, feel free to contact me through my Twitter account, Echtov. Also, we invite you to have a look at our CyberArk dedicated website. It has more useful security open source tools and publication of the research work we do. Thank you and have a good day.